Okay, good morning all. A few days ago we have started the unit number 2. Okay, that is nothing but major equipments, major electrical equipments and inductance. Okay, so in that second unit we have started the major electrical equipment, and in that major electrical equipment we have started the descriptive treatment of alternator excitation system. Okay, so we have already seen what is the alternator. Okay, after that we have seen what is the meaning of excitation system, the system which is used for providing the necessary field current to the rotor winding of synchronous machine. Such type of system is called as excitation system. Now see here, all of you know that there is a stator, right? That means every outside part of machine will be called as a stator, or stationary part will be called as a stator, and in that machine some internal part is there, and that internal part is nothing but a rotating part, and that part will be called as a rotor. Okay, so see here, in the rotor some field winding is placed. Okay, now see here, in that field winding we have to provide some necessary field current. Okay, now if suppose we have provided necessary field current with some external device, and that device is nothing but an exciter, and due to this exciter field current is provided to the rotor winding of the synchronous machine. That type of system will be called as excitation system. That means we have to provide an excitation, right? Now see here, we know that synchronous machine is not self-started machine. Okay, we have to start this machine with the help of external prime mover. Okay, now if we have used the external prime mover, that is nothing but an excitation. Okay, so we have provided this excitation to the field current of the rotor winding, so that rotor start rotating, right? So this type of system is called as an excitation system. So in other words, excitation system is defined as the system which is used for the production of the flux by passing through the current in the field winding. Now see here, I have told you that field winding is placed in the rotor. Now when the current is flowing through the field winding, it produces the flux, that is nothing but a rotor flux. Okay, so in other words, if we have to produce the flux, okay, if we have to produce a flux, or nothing but the production of flux by passing the current in the field winding, is nothing but an excitation system. Now we know that for the production, see here, for the production of torque, right, for the production of torque, or if we have to produce an EMF, there is necessary conductor, we require conductor, we require magnetic field or flux and relative motion, right? या तीन गोष्टी तुम्हाला माहिती आहे. whenever there is a requirement of induced EMF, or where there is a requirement of torque, we require three systems. First system is nothing but conductor. Okay, conductor हा खूप महत्वाचा आहे. After that we require magnetic field, and third one is nothing but relative motion. Okay, so that EMF is generated or torque is produced. Okay, we know that generating principle. Okay, what is generating principle? Can anybody tell me what is generating principle? कोणी सांगू शकतं what is the generating principle? DC जनरेटरचा प्रिन्सिपल सांगू शकतो? Yes, tell me what is the generator principle of DC generator? Am I audible? आवाज तर येतो का तुम्हाला? नसेल तर नो तर सांगा, so that I will tell you. Yes or no?
येतोय सर.
सांगा मग सांगा. See here, first of all, what is the meaning of generating principle? Generating principle means we have to generate EMF. Okay, so that whenever conductor cuts the magnetic field, right, whenever conductor cuts the magnetic field, EMF is induced. So this is called generating principle. What is motoring principle? Whenever current carrying conductor is placed in a magnetic field, it experiences a torque, right? And due to that torque, rotor start rotating. This is called motoring principle, right? So see here, first in generating principle, EMF is induced. Okay, in generating principle, EMF is induced. What is the principle? Whenever conductor cuts the magnetic field, right? Now if suppose, see here, magnetic field is there, right? If suppose magnetic field is there and we have to cut the magnetic field, so that we have to move the conductor, right? When we have moved the conductor cuts the magnetic field. That means magnetic field and conductor having some relative motion, right? Whenever conductor and magnetic field is having relative motion, so that it induces EMF. Okay, so three important things are magnetic field or flux, conductor, and relative motion for the production of EMF. Now second one is motoring principle. So instead of EMF we have to produce a torque, right? So that the rotor start rotating. Now how we can produce a torque? So see here, whenever current carrying conductor is placed in a magnetic field, right? Now see here, conductor is there, but instead of simple conductor, this is a current carrying conductor. Okay, so that this current carrying conductor is placed in a magnetic field. Now there is a relative motion between them. Okay, so that it experiences a torque. Whenever current carrying conductor is placed in a magnetic field, it experiences a force or a torque, so that the rotor start rotating. Okay, so see here, for the production of flux we require a current, right? For the production of flux we require current. Okay, we know that what is the formula for flux in terms of current? Phi is equal to Ni, where N is number of turns, right? जेवढे कॉईल असेल त्या कॉईल मध्ये जेवढे नंबर ऑफ टर्न्स असतील त्याला जर करंटनी मल्टिप्लाय केलं, दॅट इज नथिंग बट the value of flux, so that flux can be produced by passing the current in the rotor winding or a field winding. Okay, now see here, this current will be provided by some external system, and that external system will be called as exciter system or excitation system. Okay, now the main requirement of excitation system is reliability under all condition of service, simplicity of control, easy of maintenance, stability, and fast transient response. That means here these are the characteristics of excitation system. First characteristics, it should be work, or it should reliable under all condition of service. That means whenever there is used of any exciter, right, it provides some reliability under any condition. Next, simplicity in control. Every excitation system should have simplicity of control. Next, it is easy of maintenance. Next, it is having stability. And last, fast transient response should be there for every excitation system. Now in previous lecture we have already seen these things. Okay, the amount of excitation requirement, or the amount of excitation required, depends upon load current, load power factor, and speed of the machine. That means these three things should be important for the amount of excitation required. Okay, means मशीनची स्पीड किती आहे, मशीन लोडचा पॉवर फॅक्टर किती आहे आणि लोड किती करंट येणार आहे याच्यावरती आपण त्या मशीनला किती एक्साइटेशन प्रोव्हाइड करणार आहे हे डिपेंडेंट असतं, राईट. So the amount of excitation that is required to move the sync or to operate the synchronous machine, that depends upon load current, load power factor and speed of the machine, right. Now next, more the excitation is needed in the system when load current is large. I have told you that whenever there is a large load, if load is large, it draw large current. If large current is drawn, right, if large current is drawn, excitation required is more, right. When the current is large, speed becomes less, right. If speed becomes less, power factor of the system becomes lagging, right. Or whenever there is a large current, power factor is decreases or it becomes lagging. Okay, now see here, if excitation is more, load current is large, speed is less, power factor becomes lagging. Okay, now the excitation system in a single unit in which alternator has its exciter in the form of generator. Okay, now see here, whenever there is a single unit system is there for alternator, right, the exciter system are used in the form of generator. Okay, now the centralized excitation system has two or more exciter which feed the bus bar. That means see here, whenever there is a single unit, the exciter are in the form of generator, but whenever there is a centralized system, that means two or more alternator are connected with each other, then two or more exciter which feed the bus bar which is used in such a excitation system. Okay, these things we have already seen. Now we will see the types of excitation system. So first type is DC excitation system. I have already told you that. Second system is AC excitation system. Third one is a static excitation system. Okay, but this AC is further subdivided into two types. First is rotor excitation system, brushless excitation system. Okay, see here, DC excitation system, we know that DC motors are there, right. So similar way, some DC excitation systems are there, right. We know that AC motors are there, so that AC excitation system is also there. Okay, now static excitation system is there. We know that transformer, right, some static devices are there, so that some static excitation system is also there, right. But in AC, but see here, in AC, this AC excitation system is further classified into two types, that is rotor excitation system and brushless excitation system. Okay, see here, this is brushless excitation system, but in A type some brushes is there. Okay, so that it is called as rotor excitation system. So okay, so in this lecture we will see a DC excitation system in brief. Okay, this is the DC. Now we will see DC excitation system. So DC excitation system has two exciters. Okay, see here, two exciters are there in a DC excitation system. So these two exciters are main exciter and pilot exciter. Okay, see here, main exciter and pilot exciter. So these two exciters are there in a DC excitation. The exciter output is adjusted by AVR. Okay, see here, excitation, we know that excitation is a device. Okay, if we have placed this excitation device across a synchronous generator or alternator, so the output of exciter is nothing but, right, see here, the output of exciter is nothing but the cause which produces the rotation of the synchronous machine. That means the exciter output which is required or which is used to start our synchronous machine or generator, right? So this output of the exciter is adjusted by which device? AVR. What is AVR? Automatic voltage regulator. Okay, now see here. In AVR, which quantity is regulated or which quantity is controlled or which quantity is varied? That is nothing but voltage. Okay, automatic voltage regulator. So the exciter output is adjusted by AVR in DC excitation system for controlling the output terminal of the alternator. See here, output terminal of the alternator. See here, output terminal of the alternator is nothing but the voltage across load. Okay, see here, in the DC output it is adjusted by AVR. How it is adjusted? By controlling the output terminal of the alternator. Now see here, alternator is there, output of alternator is connected to the load, right? Now with the help of this AVR we can control the output terminal voltage of the alternator. Okay, so in this way this AVR is adjusting or controlling or regulating the exciter output. So next, the current transformer input to the AVR ensures limiting of the alternator current during the fault, right? Now see here, some current transformer are used in the DC excitation system, right? So see here, current transformer is a device which is used for two purpose. I have already told you that current transformer is a device which is used for two purpose. First is measuring purpose, second is protection purpose, right? See here, हे जे instrument transformer आहेत, current transformer or potential transformer, या दोन्हीचा यूज फक्त दोन गोष्टीसाठी होतो. फर्स्ट इज मेजरमेंट पर्पज साठी अँड सेकंड इज प्रोटेक्शन पर्पज साठी, राईट? जर मेजरमेंट सिस्टीम मध्ये करंट ट्रान्सफॉर्मर यूज केला सो दॅट इट ओनली एक्सटेंड द रेंज ऑफ व्होल्टमीटर or ammeter. Okay, but whenever this current and potential transformer are used in a power system, it only protect the system. Okay, now see here, we have to protect the system. How we can protect the system? कशापासून आपल्याला प्रोटेक्ट करावं लागेल? We have to protect that system from fault. Okay, now whenever there is a fault, current transformer input to the AVR ensures the limiting of the current, that is nothing but a fault current. That means this current transformer limit the fault current which is input to the AVR, right? So see here, this current transformer is nothing but input to AVR and this limits the fault current. When the field breakers is open, right? When the field breakers is open, the field discharge resistor is connected across the field winding so as to dissipate the stored energy in the field winding, which is highly inductive. Okay, now see here, some highly inductive winding is there, right? So this highly inductive winding stores some energy. Okay, whenever the field breaker is there, right? Whenever there is a field breaker is open, right? The field discharge resistor, right? Field discharge resistor is connected across the winding, and already this winding is an inductive winding. It having some stored energy, so this energy will be dissipated across this discharge resistor. Okay, and this energy is discharged when the field breaker is open. Okay, now see here, this is the structure of our DC excitation system. Okay, this is the structure of our DC excitation system. So see here, this is alternator, right? We have to excite this alternator, right? Now see here, this alternator is having some field winding, so this is the alternator field winding, right? This is the alternator field winding. So I have already told you that our DC excitation system is having two types of winding. First is a pilot exciter winding, right? sorry, so first is a main exciter winding and second is a pilot exciter winding, right? Now see here, this pilot exciter winding is there, right? And this this pilot exciter, main exciter is there, and this main exciter is having exciter winding. Similar way, this pilot exciter is there and this pilot exciter is having pilot exciter winding. Okay, now see here, CTPTs are used across the alternator which regulate or which control the fault current, right? Now see here, alternator winding is there, main exciter is there, right? See here, this main exciter is having main exciter winding. Similar way, pilot exciter having pilot exciter winding, and across the pilot exciter, field rheostat is there, right? Why this field rheostat is there? To limit the current value. Okay, we have already told you that, or you know that what is rheostat. Rheostat is required to limit the current, right? So see here, in the pilot, field rheostat is connected in series. Similar way, see here, in the field exciter, field discharge resistor, I have already told you that field discharge resistor is there, because this field exciter winding is highly inductive winding, and it is having some stored energy, and this stored energy has to dissipate across this field resistance. When this switch is connected here, circuit is completed, the stored energy will be discharged across this field discharge resistor. Okay, now see here, this is field breakers are there. Okay, whenever these field breakers are connected, this exciter will be discharge its energy across the field discharge resistor. Now here is automatic voltage regulator. This regulates the voltage, and this automatic voltage regulator will provide towards the CTPT, and then CTPT will provide the excitation to the alternator. Okay, so in this way, this DC excitation system provides the excitation to the alternator. Okay, now see here, we will see about this DC excitation. The main and the pilot exciter can be driven either by main shaft or separately driven by the motor. Now see here, in the DC excitation or in the DC motor, we have know that the classification of DC motor. Separately excited motors are there. Okay, self-excited motors are there. Again, self-excited motors are further classified into three types: series, shunt and compound. ओके, त्यामध्ये तुम्ही ज्यावेळेस स्ट्रक्चर किंवा फिगर पाहिली असेल सेल्फ एक्साइटेड आणि सेपरेटली एक्साइटेड, त्यामध्ये काय आहे, सी हियर मोटर इज देअर बट दिस फील्ड वाइंडिंग इज कनेक्टेड सेपरेटली, तेव्हा ते काय झालेले, सेपरेटली एक्साइटेड झालेले. बट इन्स्टेड ऑफ कनेक्टिंग सेपरेटली, इफ वी हॅव कनेक्टेड अक्रॉस, राईट, दिस इज कॉल्ड शंट, राईट. जर आपण शंट प्रकारे कनेक्ट केली, सो इट विल बी कॉल्ड ॲज अ सेल्फ एक्साइटेड. सो सिमिलर वे, सी हियर मेन एक्साइटेशन सिस्टम or pilot exciter can be driven either by main shaft, right, either by main shaft, that is nothing but this is the main shaft of alternator field. Okay, so we can connect this alternator field either separately or directly. Okay, so this is, see, this is already this is given in this statement. Okay, so the main and the pilot exciter can be driven either by main shaft or separately driven by the motor. Okay, but instead of separately, we have directly driven by the main shaft. Okay, so this main shaft is nothing but a direct driven exciter. Okay, so direct driven exciters are usually preferred as these preserve the unit system of operation. Okay, so instead of using separately excited driven system, we have used the directly driven excitation system. Okay, the excitation is not excited by an external disturbance. Okay, I already told you that instead of using excitation or external excitation system, we have used the direct driven system. Okay, so the voltage rating of the main exciter is about 400 volts. See here, the voltage rating of this main exciter is about 400 volt and its capacity is about 0.5%. Okay, see here, what is the voltage rating of this main exciter is 400 volt and its capacity is 5% of the capacity of alternator. Okay, 0.5% of the capacity of alternator. The troubles in the exciters of the turbo alternator, see here, this is the turbo alternator, right? So troubles in the excitation of the turbo alternator are quite frequent because of high speed, and as such generator motor driven system are provided as a standby exciter. Okay, see here, we know that some turbo alternators are there. Okay, so in the turbo alternator we know that the speed is high, right? So this turbo alternator which is require some excitation system, and this excitation system will be given as a standby exciter. Okay, so this is nothing but an turbo alternator excitation system which is called as a standby excitation system. Okay, so this is about DC excitation system. Now we will move towards AC excitation system. Is there any problem regarding DC excitation system? कुणाला काही problem वगैरे आहे? Or shall we will move towards AC excitation system? Yes or no?
No, sir.
Okay.
Yes, sir.
Okay, so we'll move towards AC excitation system. So this AC excitation system consists of an alternator and thyristor rectifier bridge. Okay, so see here in DC, right? In DC excitation system are classified into two types. First is main excitation and pilot excitation. Okay, so in the AC excitation system, the alternator and thyristor rectifier bridge is directly connected to the main alternator shaft. Okay, whenever there is thyristor rectifier bridge is connected to the main alternator shaft, then this system will be nothing but an AC excitation system. The main exciter may be either self-excited or separately excited. Okay, see here, if we have directly connected exciter to the main excitation system, then it will be self-excited, right? If this main excitation system is excited by some external sources, then it will be called as separately excited system. The excitation system may be broadly classified into two categories which are explained below in details. That means we will see in details about this AC excitation system. So these excitation system are nothing but, first is rotating thyristor, right? Rotating thyristor excitation system. Okay, now we will see about this rotating thyristor, right? We have already seen that there are two types of AC exciter system, right? And these two are rotor exciter, rotating thyristor or rotor excitation system. Second one is a brushless excitation system. So we will see in details about this. So first is rotating thyristor. So see here, the rotor excitation system is shown in figure. The rotating portion is being enclosed by the dashed lines. That means see here, this is the rotating thyristor excitation system. So see here, this dashed lines are nothing but a rotatory part. Okay, so these dashed lines are nothing but a rotating portion of the system. Okay, so see here, main exciter is there. So this main exciter is consist of CT and PT. I have already told you that the function of CT is and PT is nothing but to prevent the main alternator from the fault current. Okay, and after that some rotating system are there. In that rotating system, see here, alternator field rectifier is there, rectifier control system is there. After that power supply system is there, right? So see here, some AC excitation system is there. So these are nothing but rotatory parts. Okay, So now we will see about this. This system consists of an AC exciter, right? AC exciter, stationary field and a rotating armature. Now see here, this AC exciter is there, right? After that, stationary field is there, right? Now see here, stationary field is there. That means this exciter system is consist of three things. First is AC exciter, stationary field and rotating armature. See here, this is rotating armature, and these all things are nothing but stationary fields. Okay, the output of the exciter is rectified by the full wave thyristor bridge. We know that already. Bridge is nothing but a full wave rectifier, right? Full wave thyristor. So the output of exciter is rectified by the full wave thyristor bridge rectifier circuit, and it is supplied to the main exciter field winding. Okay, now see here, this is the rectifier circuit is there, so that the output of the AC exciter, see here, this is AC exciter, so the output of this AC exciter will be rectified by full wave bridge circuit rectifier, and this finally, if this output of the AC exciter is rectified by this rectifier unit, finally this output will be moved towards or will be fed towards main alternator. The alternator field winding is also supplied through, see here, alternator field winding is also supplied, the alternator field winding is also supplied through another rectifier circuit. Okay, the field or the exciter voltage can be built up by using the residual flux. Okay, see here, the alternator, right? See here, this is the alternator field winding. So this alternator field winding is further connected to the another rectifier circuit. See here, this alternator field winding is also, this is alternator field winding. So this field winding is also connected to another rectifier circuit. So this exciter, right, this exciter voltage can be built by its residual flux. The power supply, now see here, this is the power supply. So this power supply and the rectifier control generate the control triggering signal. Okay, so what is the function of these two devices? Power supply and rectifier is nothing but to generate the controlled triggering signal. Okay, main important of these two devices are nothing but they have to generate the control triggering signals. Now the alternator voltage signal is averaged and compared directly with the operating voltage and adjusted into auto mode operation. Okay, now see here, all these things are nothing but the control mechanism. So in that control mechanism, see here, this output, right, this output is there, so this output will be provided here, right, and now this output will be, see here, operated voltage adjustment, some adjustment are there. So the alternator output signal, now see here, some alternator output will be provided by here, some output, alternator output voltage will signal will be averaged here, and it will compare directly with the output voltage. See here, is directly compared with the operator voltage adjustment, right? See here, it is compared with this, right, and finally it will move towards auto mode operation, right? Now the alternator output voltage is compared with operator voltage adjustment, and if these both are same, then it will move towards auto mode operation. So see here, this is auto mode operation. If auto mode operation is there, then this main will be directly connected to here. Okay, whenever there is a alternator voltage is averaged and compared directly with operator voltage adjustment, okay, then there is a auto mode of operation. In the manual mode, now see here, instead of auto mode, if we have used the manual mode, okay, so in the manual mode of operation, the exciter current of an alternator is compared with the separate manual voltage adjustment. Now see here, this is auto mode operation, right? So see here, this is auto mode operation. If we have to adjust manually, now we have to take the current, right? See here, in here we have compared the voltage for automatic operation, but instead of automatic we have to go for manual. For that purpose we have to take a current from CT, right? And finally this current will be compared with, right, this excitation current will be compared with the separate manual voltage adjustment, right? So see here, this is the separate manual voltage adjustment, where is current is taken from here. There is a summer amplifier, right? So this summer amplifier will convert the current signal into voltage, and this will be compared with the manual voltage adjustment, right? So see here, this is the manually voltage adjustment and this is automatic voltage adjustment. Okay, so this is all about the rotating thyristor system. So see here, main things are there. See here, whenever there is a question asked in exam about the rotating thyristor, you have to see, or we have to just explain about. See here, these are the rotatory parts, right? So these are the rotatory parts. This is the main exciter. The main exciter should be separately excited as well as it is self-excited. When it is directly connected to the excitation system, then it shows a self-excited. When it is excited by separately external devices, it should be called as an separately excited. This main exciter is connected to a CTPT, so CTPT will limit the fault current. Again, some rotatory portion of the system are there, so this rotatory portion of the system will consist of alternator field rectifier, rectifier control and a power supply, right? Now the main excitation, now the AC excitation system will be fed to the rotatory rectifier unit, that is nothing but a bridge rectifier unit, and finally the output of this exciter will be directly given, right, directly given to the main alternator with the alternator field rectifier unit. Okay, now the rectifier control and the power supply is there, and the main function of this rectifier and the power supply is nothing but to trigger the, or to generate the triggering signals. Okay, now see here, whenever there is a AC excitation voltage is there, now this AC excitation voltage system will be compared with the operator voltage adjustment. When it is compared, then it results in the automatic mode of operation, right? Now whenever there is a requirement of manual mode of operation, we have to compare the current. That current is nothing but excitation current of the alternator, which is compared with the manual voltage adjustment. Okay, so this is all about the rotating thyristor type of excitation system. Now we will move towards brushless excitation system. So see here, this is all about the brushless excitation system. Okay, now we will see excitation, right? This is the brushless excitation system, and last is nothing but static excitation system. Okay, in this lecture we have seen two excitation system. First is DC excitation system and second is rotating thyristor excitation system. Okay, in next lecture we will see remaining two excitation system, or we will cover the remaining two excitation system in next lecture. Okay, now we will stop here. Okay.